Okay, so let's use the shell method to find the volume of the solid when the hole of radius 3 is drilled symmetrically along the axis of the right circular cone of radius 6, height 9. Oh, so there's our cone. And then we're going to basically drill out this stuff. So this is all going away. Drilling all that out. So the stuff that remains is going to go from 3 to 6. And we are going to need the equation of this diagonal line right here. And the idea is that we are going to rotate this triangle right here around the y-axis. And if we rotate that triangle around the y-axis, we will get the solid that we are looking for, the volume of the solid that we are looking for. Okay, so we will be using a vertical element because we want a cylinder. So when this vertical element at a random x is rotated around this axis right here, when it rotates around there, it's going to create a cylinder. And we know that the area of a cylinder is going to be the circumference of the base, 2 pi r, multiplied by the height. We then need to get the r and the h in terms of x. And the radius is right here, so the radius is that. And that's exactly what x represents, right? X is representing the distance from the y-axis over to that element. And so we get 2 pi times x. And then the height is right here. So the height of that element, the height of this element, is going to be given by the equation of this line. This line, if we write it in slope-intercept form, we're going down 9 and over 6. So that's going to be the slope times x. And then we have to add the y-intercept, which is 9. So that's going to be the equation of the line, which is going to correspond to the height of the cylinder. If we simplify this, we'll get minus 3 halves x plus 9. That is the area function that we then integrate in order to get the volume. So the volume will be the integral from 0, not 0. We have these cylinders that are from 3 over to 6, right? 3 to 6 is where our interval will be. So 3 to 6. And I'm going to distribute the 2 and the x inside here. So it's going to be pi. I'm going to multiply by 2. That's going to cancel the 2 in the denominator. So we're going to have negative 3 times x squared plus 18 times x. That gets rid of the fraction for us. We always love to get rid of fractions. So there's where we're at. The pi can factor to the front. And then we can do our integration. So we're going to get minus x cubed, adding 1 to the exponent, dividing by the new exponent, plus 9x squared. And this is going to go from 3 to 6. So now we're going to do our substitution. Let's get the limits of integration plugged in there. So we're going to have pi times, we plug in 6 there, yes, 216. So I'm going to put that in. Plus 36 times 9, 324. And then we subtract off, but we're subtracting a negative right there. So we're going to add 3 cubed, which is 27, but then we're going to subtract off 9 times 9, which is 81. Now we're going to do all the math right there, and I'm thinking that this will all add up to 54. So our volume will be 54 times pi.